What happened next were the traders who kind of traded with the mountain men, and then you had the forts that came along and protected the traders. Then you had the settlements build up along the forts, and there was kind of a progression and a sequence. And I've argued that the Apollo astronauts represent the mountain men, as it were. They represent the legends and the mythical beings, that where we are now is to try to put down some roots and some permanence.
If we're to do anything other than visit the moon sporadically and maintain a base there, as we do today in Antarctica, if we are to indeed grow and flourish there, we must develop the capability to live off the land.
Water, shelter, hunting grounds, fertile soil. Such are the resources settlers have sought all over Earth. What does the moon have to offer? No life has ever sprung from this surface. Days and nights last 2 weeks each. Temperatures soar to 260 degrees Fahrenheit and drop to minus 270. Cosmic and solar radiation sear the land. Here, the laws of nature rule a hostile and alien world, as astronaut Dave Scott so clearly demonstrated.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
In this vacuum, there is no atmosphere, no weather, no sound. Because the moon is smaller than the Earth, its gravity is only 1/6 as strong. A fully suited Apollo astronaut would tip our scales at 360 pounds.
Off the ground, one more. There we go.
On the moon, he weighed a mere 60. All this conspires to make the loose soil a serious nuisance.
Well, everything's getting awful dusty. Boy, everything is just full of dust. There's got to be a point where the dust just overtakes you and everything mechanical quits moving.
One astronaut would say his dust brush was his most important tool. Any disturbance of the soil lifts a spray of particles which tend to cling to anything they encounter.
Can I change your oil?
Including camera lenses.
Thank you, Dino. It looks much better.
It's hardly a Garden of Eden. And yet this sterile world has much to offer if you know what to look for.
Well, I think the moon's reputation for being barren is accurate by Earth standards, but not by planetary standards generally. I think it also helps that I happen to be a chemist, so I think in terms of what chemical elements are available. We can always make what we need from them, and of course all the elements are on the moon. The big resource that the moon has in terms of materials, of course, is the ubiquitous lunar soils. They're all over the place. For example, within a cubic meter of lunar soil, you have all the carbon, hydrogen, nitrogen, oxygen, and other constituents you'd need for a lunch for 2 people. You can make 2 full-size cheese sandwiches. You can have 2 12-ounce sodas. You don't even have to cheat and use sweetener. You have enough for real sugar. And you can have a couple of plums and you'll still have everything but hydrogen left over. Everything that we want is there, it just isn't there in the forms that we're used to using here on Earth.
The challenge is to unlock the moon's resources. Haskin is developing extraction techniques. He chemically simulates a tiny drop of lunar soil. Electrodes are inserted. In a furnace heated to 2,600 degrees Fahrenheit, The sample is melted. Electricity flows between the electrodes and separates the soil's components. Iron and silicon will collect at one electrode. Bubbles of pure oxygen are released and will collect at the other. This basic experiment shows that simple principles can be applied to retrieve valuable resources on the moon. The production of oxygen could become a lunar colony's key industry, providing both life support and propellant for transportation. Metals derived on the moon could be used for manufacturing and repair of support systems. There are riches to be mined in the lunar soil, but the technology to do so must first be developed on Earth. That's the hitch. Nearly half a ton of rocks and soil were returned from the moon. It is treated as the rarest, most precious material on Earth. NASA distributes only minute amounts to researchers. All common elements exist on the moon, but some have combined into minerals unknown on the Earth. Lunar soil contains a high proportion of glass, formed when meteorite impacts melted the surface. The tiny beads can make the ground slippery, as the astronauts found out.
Further down. Hey. Uh-oh. Ah, rat. Okay. Up, here we go again. Give me a help.
They say give it a slight rotation clockwise as you're lifting out.
Okay. Stay there. Stay there.
To design equipment to process lunar soil by the ton, to test a hunch that moon dust can be turned into concrete or a fertile plant-growing medium, how could anyone succeed, limited to a thimbleful of the real stuff? The answer may be in our own backyard, in a deserted quarry near Duluth, Minnesota. Geologist Paul Weiblen studied the first Apollo samples in 1969. Years later, he was struck by their chemical similarity to these rocks. They're the closest terrestrial match to moon rocks yet identified. To come up with a reasonable substitute for the powdery lunar soil, Weiblen had to take matters into his own hands. In the course of an afternoon, he accomplishes what took 3 billion years of meteorite showers on the moon. Equipment once used to process iron ore pulverizes the rocks. To simulate the intense heat of an impact, the soil is run through a plasma reactor at temperatures up to 5,000 degrees Fahrenheit. The end result is called Minnesota Lunar Simulant, or MLS. It's not a perfect match of lunar soil, but its similar bulk chemistry, mineralogy, and microscopic beads of glass make MLS an important research tool.
I'm particularly interested in this work on simulants because it provides a way of doing studies now that will enable future people on the moon to use the lunar materials for plant growth, to recover oxygen, with all the mistakes having been made first on Earth.
Minnesota Lunar Simulant is available to researchers by the kilogram for a nominal fee. As interest grows in developing lunar industries, orders have come in from around the world. At Shimizu Corporation, engineers use MLS to experiment with lunar concrete. Every pound of supplies launched from Earth costs something near its weight in gold. Learning to build with local materials will be the only viable solution for construction on the moon. Stress tests show the simulated lunar concrete to be at least as strong as the terrestrial variety. But making concrete on the moon will require the development of another resource, lunar water. At the University of North Dakota, researchers have devised a way to get water out of rock. They heat lunar soil simulant to 1,600 degrees Fahrenheit, then introduce hydrogen into the system. As the gas flows through the soil, oxygen is released to combine with the hydrogen. The resulting steam condenses into water. Processing lunar soil may look easy, but it means generating high levels of electricity and heat on the moon. At McDonnell Douglas Space Systems Company in California, engineers have found an innovative solution. They routinely melt lunar soil simulant in a graphite mold at over 2,000 degrees Fahrenheit, but they use no electric furnace. They harness the oldest source of energy around. In the 1980s, McDonnell Douglas developed massive solar concentrators as part of a program on alternative energy. Today, these seem a promising technology for the moon. The mold is mounted in the center of the concentrator. Sunlight is focused on it. In only 20 minutes, the soil inside reaches 2,200 degrees and melts. On the moon, where there is no atmosphere, the sun is even more powerful. The mold is left to cool overnight. 24 hours later, it is still warm to the touch.
See if it even opens up.
The experiment produces a tough, ceramic-like material that is nearly twice as strong as concrete. Someday, materials like these could be used to build habitats or to pave the roads to lunar cities. There is gold in those hills, perhaps enough to sustain a lunar colony. The Apache Point Observatory in Las Cruces, New Mexico, is built of lightweight materials with simple working parts.
There we go. Good.
It is also remote controlled by Jack Burns, an astronomer at the University of New Mexico over 100 miles away.
Oh, no, I'm sorry.
Burns sees Apache Point as a prototype for a lunar observatory controlled by astronomers on Earth. But he also has a grander vision for astronomy on the moon.
The moon, for our purposes in astronomy at least, is a dead world, geologically speaking. The ground is extremely stable. There is 8 orders of magnitude less geological energy on the moon than on the Earth. Now that's important to be able to do what's called optical interferometry, to be able to take several individual optical telescopes, link them together as a single, very powerful telescope to look out at the cosmos with extremely high resolution. We can't do that from the Earth, not only because of the atmosphere, but also because the ground is very unstable on the Earth.
An array of optical telescopes, several miles in diameter, could yield fantastic resolving power, up to 1 million times better than anything possible on Earth.
Looks like
But even a modest lunar observatory could perform valuable study.
we have, once again, looks like most of the...
Yeah.
If we had a lunar-based telescope, then we'd be able to zoom in by several factors of 10 more than what we've got here and really look in detail at where these stars are forming. One of the real exciting parts, though, of these new telescopes will be the opportunity to potentially detect other planets in other parts of our galaxy. That's the first step in being able to see whether or not life on other planets and other worlds is a real possibility.
For all our probing of the night sky, we have yet to find a single planetary system like our own. Observatories on the moon will join the ongoing search, scanning the heavens for telltale signs of planets orbiting a distant star, cryptic but intelligent signals that will tell us, you are not alone. The moon holds a grand vision for the future, full of hope and promise. But for now, in the late 20th century, we remain earthbound. How do we get back?
I think our approach to return to the moon cannot be and should not be thought of as one big mission. What we really should think of it as is recreating an infrastructure, a transportation infrastructure, like an interstate highway, that we once possessed. We had all those elements. They could have been modified and upgraded a little bit with today's technology, but we, the United States, owned a lunar transportation system. We know how to do it. Once we recreate it, we will have the capability to do any number of missions at relatively small additional cost, and indeed we will have much of the capability we need to go forward to Mars.
During Apollo, each launch was separate and unique, each a one-shot expedition. Lunar advocates propose a different approach. First to return to the moon will be satellites and robotic craft to map minerals and resources and determine the site for the first lunar outpost. The first crew would be equipped for a stay of several weeks. Their landing would follow that of a cargo ship containing a habitat, life support, and science lab. Teams of specialists would rotate periodically. Geologists would explore. Engineers would develop new technologies. Construction robots would be controlled by operators miles away, perhaps even on Earth.
ダイレクト終了。
Sparing human workers the dangers of prolonged exposure to the harsh environment, robots would assemble the building blocks of a lunar base.
機械系減点。
Environmental engineers would master the art of recycling precious air and water in closed-loop systems. Manufactured directly from lunar soil, huge solar panels would convert light into electricity. Solar power collected on the moon could even be beamed to an energy-hungry Earth to become the first extraterrestrial import. The moon might also provide another energy resource. Helium-3, a rare isotope present in minute amounts on Earth, but mineable in the lunar soil. In the next century, scientists hope to develop new fusion technology for more efficient nuclear power. Reactors fueled by helium-3 imported from the moon could provide clean, safe nuclear power. Commerce between Earth and the moon could build financial independence for a lunar colony. Eventually, humans would bring the seed of life to the moon, creating habitats where plants recycle water and oxygen just as they do on Earth. Some say a lunar colony could ultimately become self-sufficient as new forms of farming and space agriculture are developed. In a distant future, some see the moon as a welcome oasis for workers assigned to duty on space stations and as a supply post for missions to Mars and beyond. Today, not a single official dollar has been committed to this vision. To some, it may even seem far-fetched. But stranger things have come to be. In the 1930s, a film called Trip to the Moon depicted one man's vision of the future. Konstantin Tsiolkovsky, a Russian schoolteacher, had dreamed of space travel all his life. A team of daring explorers traveled by multi-stage rocket.
Okay, the first stage was very smooth, and this one is smoother.
They mastered the control of complex technology.
Houston, Apollo 11, Star 40 has just disappeared now in the section.
They enjoyed the thrills of weightlessness. Precisely on course, they approached the moon with trepidation. Then they landed in an unusual vertical configuration.
Contact light. Okay, engine stop. ATA at a descent.
We copy you down, Eagle.
Human intelligence may fulfill itself in space or discover its limits there. Are there limits to technological progress? Are there limits to our imagination? Perhaps this is the one great lesson we have learned from going to the moon. Given the courage to dream and the will to achieve, we can control our future.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Ladies and gentlemen, we hope you have enjoyed your visit to Tranquility Base Museum and that you found the historical presentation inspiring. Should you find yourself pining for those early days of lunar exploration, just remember, even though the moon has become a familiar and comfortable place, the frontier is still out there, just beyond our reach, just beyond our wildest imagination.
In The Professionals next tonight, Watching the Detectives follows Peter Clark as he attempts to recover stolen boats and stop insurance fraud.